Hello, this is a demonstration on multiple linear regression. Okay, now we are going to use the Boston dataset. You may find out that in the textbook it says that this set should not be used, but we are still using it just for demonstration. First of all, I would like to clear all the variables. So I'm inside the variable explorer. Let me click this remove all variables icon. Now all variables are removed, and then let me remove all the console output by clicking this icon. Now I'm starting with a clean console. So let me try to run this program. I can run the whole program by using run and click run here, or just the function key F5, or just this green arrow. So let's do it. Now, as you can see, in the console, it shows that the program quickly runs and finishes quickly. Okay, and this is the output. The output is from this line. Okay, and finally, it prints out the score of the fit, which is the R squared. Okay, and it's 0.7340. Which is the same as stated in the book, because I use the same random state. If I change the random state for, let's say, to 42 or 43, and then we try to run again, and then we go back, and as you can see, because I use a different random state, now the R squared is different. Now, what happens if I run this line by line? So let's try to clear everything here. So when I run it, I'm going to change something first. So I'm going to, instead of A and B, I'm going to change to the actual feature names here, like LSTAT, and then the other feature is RM. Let me save this. Okay. So now I'm going to go to the first line, and I'm going to hit F9, the function key. So as you can see in the console, it's being executed line by line. And you may notice that line 11 is quite different from the book. Okay, I'll explain more in the classroom. Okay, but this one is a bit more elegant. It's very simple. Okay, I just want to create the feature matrix X, okay, using only 2 columns from the existing data frame, which has a lot of columns, which has 14 columns. I just want to use the LSTAT and the RM. So let's continue. So I have the X, which consists of only 2 columns after line 11. Okay, let's continue with creating the Y. And notice that I use the big X, the capital X, and lowercase y to be consistent with most machine learning examples. And then I do the train test split here. And then I create my features to degree 2. Okay, and then now I'm create. Now this does not actually create the features. This is just saying that I'm going to create features which is up to degree 2. This really creates those features, this fit transform method. Okay, so let's print them out. Previously we used just A and B, okay, to make it simple. Now let's take a look. And as you can see, it's quite long. The first term in the feature matrix is 1, is always 1. And then in the LSTAT, we have the LSTAT. Actually, I think I make a lowercase l here. Okay, and then the RM, which is just like in the linear polynomial regression. And then we have the LSTAT squared, and then LSTAT times RM. Okay, and then have RM squared. Okay, so all these terms are to degree 2. Okay, and then I continue my execution. There's no specific output. And now I'm doing the fit transform here, which is really the training using the transformed model. Okay, based on these two features raised to degree 2, and then finally the output. So that's it. Thank you. Okay, now let's take a look at the actual features that is used in the polynomial regression training. Okay, remember in the linear regression we were just using the x. Okay, let's take a look at the x itself. Okay, so that's the x that we used in the normal linear regression. Okay, but in the polynomial regression we raise everything to degree 2. Okay, which means that we are going to use this one and this one, and then the L stat squared, okay, and then L stat times Rm, okay, and then Rm itself squared. So what does the data look like? Well, to take a look at the data, we have to take a look at the feature matrix that is used to train, okay, the polynomial regression. Okay, so let's look at the fit method here. It uses X-train poly. So let's look at X-train poly. Now, as you can see, the first term is 1, okay, which is the 1 here, okay, and then L stat, which is L stat here, and then Rm, which is Rm here, and then L stat squared, okay, which is this term squared. So this number times itself is 172 something. This squared is 130 something. Okay, and then this term is this number times this number. So you can quickly tell that 6 times 13 is about 78, and then this is 80. So this is column 4 is just this column multiplied together. And then lastly, column 5 is this column squared. Okay, so this itself squared is almost 37, and so on. So that's it. Thank you.